Okay, the next function we're going to take a look at is f of x equals negative 3 over 2x squared minus 2x plus 8. So the first thing I would notice about this is this is in standard form. And because I'm hoping to graph this, the first thing I would think is, what's my vertex? To find the vertex in standard form, you first want to know the axis of symmetry. So we want to find x equals negative b over 2a. Well, for this, a is negative 3 over 2, b is negative 2, and c is 8. So then I am going to do x equals negative b, so that would be positive 2, or the opposite of b, you can think of it, over 2 times negative 3 over 2. Well, 2 times negative 3 over 2 is just negative 3, so I have negative 2/3. So the x value of my vertex is negative 2/3. So to find the y value, I'm going to plug that in. I want you to become comfortable with working with fractions. So f of negative 2/3 is what we're trying to find, is equal to negative 3 over 2 times negative 2 over 3 squared minus 2 times negative 2 over 3 plus 8. And then this is just chicken scratch, like it's just figuring out what this equals. Negative 2/3 squared is 4/9. And that will become plus 4 over 3 plus 8. I would cross cancel, so this would become 1, that would become a 2, this would become a 1, this would become a 3. So then I have negative 2/3 plus 4/3. And then because those are both thirds, I would change 8 into thirds. What divided by 3 is 8? 24 divided by 3 is 8. And then negative 2 plus 4 is 2, plus 24 is 26 thirds. And that's the same thing as 8 and 2/3. Now, typically, I prefer improper fractions. Not to say that a mixed number would be incorrect, but I typically prefer just to leave it as 26 over 3, except when I'm graphing, because I can more easily graph 8 and 2/3 than I can 26 over 3. Quickly, I should say. All right, so now this is a little bit tricky because since the vertex is not at an integer, it's going to be a little bit harder to choose points equal distances away from it. But we're just trying to get a pretty good sketch. So the first thing I would graph is that negative 2/3, and then assume that line. Let's see if I can do this again. Make that a little bit better. So negative 2/3, 1, 2, 3, 4, 5, 6, 7, 8, and 2/3 is about there. So my trick still works with over 1, down, in this case, because it opens down, the 1.5 times whatever it's supposed to be. But that's going to get a little bit trickier with the fractions. So if you want to just plug and chug numbers in this case, you can. Whatever you need to do to get some more points. I am going to find a few more characteristics. So the first thing I'm going to do is find the y-intercept, because it's easy. So if I plug in 0 for x, I am just left with 8. So I have 0, 8, which will be right here. Now remember, because the vertex was at negative 2/3, I would have to go 2/3 over to get another point at 8, which is a little bit trickier. We just have to make sure that it's symmetric. So it's 2/3 over. So if I went 1 over, it would be down 1.5. But going down 1.5 from 2/3 gets a little bit tricky just to have it be pretty accurate. So honestly, I think it would be easier just to plug in a number. So for instance, I would plug in 1 and see what the output would be. So just make a quick table. So if I plug in 1, then I would get negative let's rewrite this. Let's write y equals negative 3 over 2x squared minus 2x plus 8. So if I plug in 1, that's negative 3 over 2 minus 2 plus 8. So negative 2 plus 8 is 6. So 5.5. Nope, 4.5. So 1, 2, 3, 4.5. And then if I plug in, let's see, we already have a point kind of around negative 1. We could do negative 2 maybe. So negative 2 squared is 4. 4 divided by 2, so that's negative 6. Plus 4 plus 8. That's not seeming correct. Oh, yeah, it is. So negative 2 plus 8 is negative 6. So negative 2, 1, 2, 3, 4, 5, 6. And so it doesn't look, there's not some, I didn't choose symmetric points, but that's okay, because it's still going to make a nice, pretty parabola. All right, so now let's find our x-intercepts. So I'm going to set the equation equal to 0. And then I'm going to either factor or use the quadratic formula. So now in order to do either of those, I think it would be easier to get rid of the fractions. I'm going to multiply everything by 2. Now I would not graph this equation. The graph of this would look different. But to solve, it's a little bit easier. And honestly, I would probably multiply by, I could actually go back and multiply by negative 2. And that's going to make that positive leading coefficient, which is nice. So if I multiply everything by negative 2, I'll just rewrite it. I get 3 over 2. No, I don't. I get 3x squared plus 4x minus 16. And that's just kind of nice because it gives me nice, pretty integer values. Now, did I have to do that? No. Could I work with a fraction? Yes. Whoops. I'm not on my Cricut. So then I could do the quadratic formula now, or I could try and factor. I actually already know it's not going to work. A quick trick, in order, the opposite of b, I showed you this the other day. So b squared minus 4ac. If this is a perfect square, then I know it's going to factor. So 16 minus 4 times 3 times negative 16 is going to give me something that is not a perfect square. So 16 times 4, 32, 64. 64 times 3 is 192. So that's 16 plus 192. And that's going to give me 208, which is not a perfect square. I'm going to double check my math there. Mental math really quick. Yep, 208. So we have negative 4 plus or minus the square root of 208 all over 2 times 3. So the square root of 208, I need a perfect square that goes into that. That's going to be divisible by 4, and I think that's 52. Now, I quickly did some mental math. I knew 4 went into it, but I know that the 4 also goes into 52. It's 4 times 13. So then the square root of 208 ends up being 2 times 2 times radical 13. I know I'm going a little bit fast here, but I hope that you remember your radical work from both geometry and algebra 1. And then we can reduce this. So divide the coefficients by 2. So I have negative 2 plus or minus 2 radical 13 all over 3. Now, had you never multiplied by 2, to be honest, when I did my notes key, I did not multiply by 2. At the very beginning of solving this, you still get the same answers. So these are your zeros. And so your x-intercepts are negative 2 plus 2 radical 13 all over 3, comma 0, and then the minus. kind of big. Sometimes students don't draw a large fraction line like I just did, and they only put the second half in the fraction. That whole thing is one giant fraction in this case. Last thing, I'm going to look at the graph to do domain and range. So I'm going to scroll way back up. I'll do it in a different color so you can kind of follow along. How about bright blue? Do dark blue, actually. So my domain, I'm just going to do, let's say, interval. So my domain is all real numbers, which is negative infinity to infinity. And then my range, it's opening down, so it starts at negative infinity and goes all the way up to 8 2/3. And that is included, so it's a bracket. Make that obvious. And that's it for this example. I hope you're having a good day. I'll talk to you soon.